Hi, this is Tony Northrup for TrainSignal, and this video session is going to cover how to configure devices and device drivers in Windows 8. This lesson is specifically for the Microsoft Certification Exam 70-687, and it covers Objective 2.1. Now, the official objectives have three sub-objectives: install, update, disable, and rollback drivers, resolve driver issues, and configure driver settings. Good news, these are all pretty straightforward. It's going to go really quickly and everything is hands-on, so this should be a fun lesson. Let's get started by demonstrating how to update drivers. This is my Windows 8 Enterprise computer, and figuring out how to update drivers couldn't be easier in Windows 8. I'm just going to type update drivers from the start screen and then search the settings, and you'll see there's an item here, update device drivers. So I'll click that and it opens Device Manager, and you don't have to go that way. You can open up Device Manager any way you'd want. Now, Device Manager lists every driver that's installed on your computer. So you can see that it's organized by different types of hardware: batteries, computer, disk drives, display drivers, keyboards. Every piece of hardware on your computer has its own driver. And that's what a driver does. The driver interfaces between the operating system and every hardware component. So Microsoft and Windows, they support literally hundreds of thousands of different pieces of hardware, and there's no way they could make Windows talk to each piece of hardware independently. It would just require way too much code, and they'd have to be updating Windows all the time. Instead, what they do is they make Windows talk generically to any keyboard or any monitor or any network adapter. And then the hardware manufacturers develop these little drivers that translate from Windows kind of generic network adapter speak, say, to the communications that their specific hardware device needs. So these drivers are specific to every hardware component in your computer, but they allow that hardware component to speak the general Windows language. So any hardware component that comes out, the manufacturer just needs to make a driver for it, and then it will work with Windows, and it works kind of magically. There's some caveats though. These drivers run at what's called Ring 0. They run in kernel mode, which means they can do anything on the system. Literally anything. They could look at the memory used by other applications. They could install malware or rootkits. They could do dangerous stuff, much more than the typical app that you might download would be able to do. Therefore, you need to be really careful about drivers, and Microsoft likes to have their drivers signed. The signing process involves Microsoft kind of checking out the code that the hardware manufacturer made and making sure that it doesn't have any malware or it doesn't do anything bad, that it doesn't open up any security and vulnerabilities that other malware could attack and take advantage of. So basically, Microsoft likes to sign drivers because drivers have the potential to do a lot of harm, not necessarily deliberately, but even just accidentally through negligence if the driver developers happen to not be that well versed in security and they leave some door open that malware could attack. There are two types of drivers, signed and unsigned. Signed drivers are clearly more trustworthy, as any malware developer could create an unsigned driver and put it out there on the internet. However, there are legitimate reasons why you might want to use an unsigned driver. For example, Intel here would always sign their drivers, but if they had something in development, if they were currently troubleshooting a problem that you had with their driver, they might issue you an unsigned driver. Now, by default, you wouldn't be able to install that unsigned driver in 64-bit versions of Windows, and you would be able to install it in 32-bit versions of Windows. In 64-bit versions of Windows, you'd have to disable driver enforcement, a simple startup task that we cover in a different lesson. So having a signed driver takes a little bit longer. On the other hand, if Intel wanted to immediately push out a new driver, maybe they're fixing a problem with their old driver, they could release an unsigned driver just on their own website for you to download. So this difference between signed and unsigned drivers is important to understand in the context of updating drivers, because signed drivers you can get directly from Microsoft, and unsigned drivers you can get directly from the websites of the different hardware manufacturers. There's one more catch to it. If you're running 32-bit Windows, you can install signed or unsigned drivers. If you're running 64-bit Windows, you can only install signed drivers from Microsoft, unless you are a developer, basically. So, having established the difference between signed and unsigned drivers, let's talk about how to update drivers. Once you're in Device Manager, it's pretty easy. You just find the driver you want to update, you right-click it, and then you click Update Driver Software. And this prompts you for two different ways to update your driver. You can browse your computer for the driver software. If you happen to download it from your vendor, or if the vendor shipped a CD or flash drive or something with a driver installed on it, you would click this and then just browse to it and install it on your computer. You might also have drivers on your local network somewhere for all the common hardware in your organization. If you just want to get the latest version that Microsoft has, you'll click this first option here, search automatically for updated driver software. Now, this is going to look for signed drivers, of course, which is generally what you want anyway. So in this example, it determined that we already had the best driver available. There's nothing newer or better for this particular adapter. But if it had found something, well, it would have just installed it and it would have been really straightforward. So that's how you manually update a driver, but you don't have to manually update drivers. You can also automatically update drivers. So for a single computer, what you do is open up the System Properties dialog box by right-clicking Computer in File Explorer and then clicking Properties. Then click Advanced System Settings. Select the Hardware tab and click Device Installation Settings. So the Device Installation Settings dialog box gives you two choices here. You can choose to automatically download driver software and realistic icons for your devices, or you can click No and choose other options. So you can see here, if you pick No, you have the option to still get the best driver software from Windows Update, or to never install driver software. Now, the reason you might choose never install driver software is maybe you work in an organization that really closely manages the software that gets installed on their computers. Earlier, I described the potential dangers of drivers and what they were really capable of if something went wrong. So some organizations, say government organizations, want to monitor this really, really closely and do their own testing on every driver that comes through. Yes, even Microsoft's signing testing might not be enough for them. So in that case, they would never want these drivers to be installed. They'd want to manage every single one individually. Now, for me personally, most small organizations and even most enterprises, the best thing to do is to simply install drivers that come directly from Microsoft. After all, these are the drivers that Microsoft thinks are the best version. They can improve reliability, and updates tend to also eliminate security vulnerabilities. So this is my recommendation, is to go with the default setting, which is to install them automatically. Now, you can also change this for many computers in your organization by using group policy. So I'll jump over to my Windows Server 2012 computer and we can check out how to update the group policy from there. Here we are in Windows Server 2012. This is a domain controller. So I'll open up the Group Policy Management Editor and edit my default domain policy. Now there's a particular policy under Computer Configuration, Administrative Templates, System, Internet Communication Management, and then Internet Communication Settings. Over here I'll find the policy Turn Off Windows Update. There it is. Turn off Windows Update Device Driver Searching. So if you enable it, Windows won't go looking for new drivers, and like I said, that could be a good thing. If you disable it, then Windows will look for new drivers. And again, this applies for every computer in the organization. And this applies for every computer that the GPO is applied to. So it could potentially be every computer in your organization. Now, there's another policy I should show you as well. Under device installation here, we have a couple of policies that relate to the device drivers. If you specify the search server, this will allow you to specify a local Windows Update server. Organizations can set up basically a localized version of Windows Update where they get to approve or even add updates that get distributed to all the computers. This gives them control over which updates individual computers receive. It also helps centralize the management and reduce internet bandwidth usage because, thousands of computers could be downloading updates from the local computer instead of reaching out across the internet to Microsoft. So if you use one of these Windows Update servers, you'll want to specify that they use the managed server or go to Windows Update. The other setting you should look at here is specify search order for device driver source locations. When you enable this, you can specify whether you always search Windows Update or if you search Windows Update only when needed. If you don't ever want to pull drivers down from Windows Update, select Do Not Search Windows Update after enabling this policy. This wraps up this sub-objective, so let's move on to the next. In this sub-objective, we'll cover how to manage drivers other than updating them. So let's jump back to Windows 8. Now I still have Device Manager open here, but I'll show you another way to open it from the start screen. This is the quickest way to open it. Type devmgmt.msc. That happens to be the name of the Microsoft Management Console for the device drivers. So this pops it right up. Now, to manage any driver, you can simply right-click it and then click Properties. And on the Driver tab here, you'll see a list of different options. You can view the details of the driver, which tell you the specific files that the driver is using. You can also see file versions down here. So if you're working with a support person and they ask you, what version of the driver do you have? This is the process you would follow, and this would be the version of the file. If you need to copy a driver from one computer to another, maybe a driver is working on one computer but not on another and you don't know where the files are hidden, look here and you can see exactly where the files are. You'll see a button here for updating a driver too, though that's not the only way to do it. And if you want to uninstall a driver, you can click Uninstall here. Uninstalling it is a really useful process for troubleshooting. It removes all traces of the driver. And the next time you connect the hardware, Windows will try to reinstall the driver. So if you ever feel like it might help just to uninstall and reinstall a driver, maybe something got corrupted, maybe you're not sure about the version or whether it's working properly, give it a shot. Uninstall it, restart the computer, reconnect the driver, and reinstall it. Now you'll see a couple of options here that are disabled for this driver, but won't be disabled for other drivers. Rollback driver is available if a driver was installed and then later updated. When you click rollback driver, it uninstalls the newest version and restores the older version. So you would use the rollback driver option if you recently updated a driver and you noticed problems with the device, or problems, say blue screens or stop errors. If Windows was crashing after you updated a driver, give the rollback driver option the chance to see if that will fix it. This goes back to the older version, which might not have had the problems. If you simply want a device to be disabled, click the Disable button. That's different than uninstall. If you uninstall, the next time Windows finds a device, it's going to try to reinstall it. If you disable it, Windows will simply ignore that forever. Now, disabling the driver will solve any problems related specifically to the driver, but they might not solve problems caused by the physical device itself. So if you have a network adapter in the computer and the driver is causing Windows to crash, disabling that driver will solve the crashes. If you have a network adapter in the computer and there's physical problems, maybe the adapter is sending out electrical signals across the wrong connections and causing the computer to crash, well, disabling the driver probably isn't going to fix that. It might not anyway. The only way to fix it would be to physically remove the device. So as long as we're looking at the driver properties, we can look at a couple of other tabs here. The Details tab tells you just a massive amount of information about the device. We can look at the manufacturer here and different object names. These settings are going to be different for different types of drivers and specifically different manufacturers. But you can often find really useful information in here. For example, this has the install date that tells you exactly when the driver was installed. So like I said, this tends to vary, but if you're troubleshooting a problem with a particular driver, it's useful to give this a look and see if you notice anything unusual. The Events tab shows you different events that have been registered by that particular driver. This includes when the driver was originally registered, as well as any problems that the driver might be experiencing. Let's take a look at this driver here, since it seems to be showing a problem. Well, you can see it doesn't have any problem events, but you can see the time that it was initially configured. You can also look in Event Viewer and find the same information, but for me, I find it easier to look on the Events tab here because it narrows it down to events related to the specific driver, and in Event Viewer there tend to be tens of thousands of different events that you have to weed through, so I find it a little bit easier. Finally, the Resources tab here shows you, when a device is functioning properly, which resources it's using. So you can see the standard keyboard here, because this is an old school PS2 keyboard and not a USB keyboard. It actually has to use an IRQ. And if you don't know what that is, that means you're just not as old as me, because back in the old days, all hardware had to have a particular I/O range and a particular IRQ assigned. So this is kind of a relic from the old days. USB doesn't work like this. But know that these are various system resources that had to be allocated on x86 based computers. We're talking about like an architecture from the 70s, basically. It's now a little outdated, but the Resources tab is useful for viewing which of these need to be managed. And, you know, in the 80s and 90s, these types of conflicts were common. You'd have two different devices that were trying to use the same I/O range or the same IRQ, and you'd get a bunch of crashes. I haven't seen anything like that in more than a decade, so I don't think this is going to be a common thing that I have to troubleshoot. But for the exam, know that if you want to look at what the IRQ or I/O range is for a device, open up the properties from the device manager and then check the Resources tab. So that's really all there is to it for managing drivers. So let's move on to the next sub-objective. This last sub-objective is troubleshooting drivers, and this is something that I've already hinted at. I've already given you some techniques like rolling back drivers, but I want to show you one more tool, which is Reliability Monitor in Windows 8. So let's switch over to Windows 8. From the Start screen, I'll search for Reliability, and then search the Settings, and you can see View Reliability History. This opens up Reliability Monitor. Now you can see this computer isn't old enough to have any problems, or maybe it's just too reliable. But fortunately, I have access to an exceptionally unreliable and heavily used computer. This computer happens to be running Windows 7, but Reliability Monitor hasn't changed a bit. So let's jump over to Reliability Monitor on my Windows 7 computer. Now this computer has some real activity on it. And if you look at the different components of Reliability Monitor, you see a lot of useful information. First, you see this blue line here, and that is not among the pieces of useful information. This blue line is this weird metric that it calculates about the overall system reliability on a scale from 1 to 10, and I have no use for that. So ignore that blue line. What is interesting are these different red X's here. The red X's, as you see, correlate to application failures, Windows failures, and miscellaneous failures. There's also icons for warnings and information. You can view this chart in either days or weeks. The information gets aggregated if you search by weeks. And of course, you can browse forward or backwards through time. So I find this terribly, terribly useful when troubleshooting problems. Here's the reason. If you're starting to experience random crashes with your computer, Reliability Monitor is a quick way to go back and see when these problems started. Now, if it's your own computer, you probably remember. You probably think, well, these things started to crash in the last week. I should look and see what I updated in the last week and maybe roll that back to reverse the problems that I introduced. But if you're an IT support guy and somebody calls you and they just say, you know what, my computer's crashing, I want a new computer. What you can do is you can open up Reliability Monitor and get the computer's more objective record of what's changed and when errors started to occur. I find that the computer has a much better memory than the typical user, so it'll give you much more precise information and allow you to troubleshoot it. Now, this particular entry shows some driver-related errors. You can see these critical events here, and Windows is reporting an error and describing it as a video hardware error. Now, you can click this check for a solution link. It has never done anything useful in my experience. This goes out and communicates with a Microsoft service, and it kind of sends the signature for the error to see whether there's any solutions that match that particular problem. Oh, no shocker there, no new solutions found. I've checked this on like dozens of problems over the last 4 or 5 years since whenever they've had this, and I've never found a solution. It doesn't hurt to click it, but let's not get your hopes up, okay? So this particular error is useful. It tells me it's a video hardware error. So what I could do is go into Device Manager and check the current version for the video adapter and maybe see if there's a new version of the video adapter. Video adapters are probably the most problematic driver that I experience over the large number of computers that I've managed. I don't know why video drivers tend to be the most unreliable, but that's the way they work. The informational events are also really useful because, as you can see here, they'll show you when a new driver was installed. You can see on November 18th of 2012, this particular computer had the driver for a USB camera installed. This could also be an update. You can also see the history of Windows Update installations in Reliability Monitor. So here's how you can use this. If you discover that there's a whole bunch of errors that started on November 18th, you can look in Reliability Monitor and see what might have changed about that time. You can see, oh, these new drivers came in, and then from that day forward, there were a bunch of crashes. That doesn't give you a perfect correlation, but it gives you a clue, right? You can think, well, I'll try to roll back that driver using the techniques I showed you earlier. And if the problem goes away, well, you've solved it. Congratulations. Maybe you contact the hardware vendor and say, you know, I had this problem. It went away after I rolled it back. It might be something you want to look into. Now, it could also be coincidental. It could be that this driver happened to be updated on the 18th, and at the same time, one of my memory chips developed a problem, and that's causing the error. So you can't be sure that the problem is going to be related with events that occurred about the same time. But Reliability Monitor gives you an important clue, and often it's really helpful. This is Tony Northrup for Train Signal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.